Hey guys, I'm going to do a quick functions review with you for your test tomorrow. So whether you have me or you have Miss Burat/Miss Bluen right now, this is going to kind of just be a very basic review of all the function stuff. And then I am going to kind of start this test review with you. And I have a couple of questions marked that I'll kind of do with you, and then you'll go ahead and finish the rest on your own. All right. So let's talk big picture first, and you may want to write this. I'm just using a blank piece of paper. So if you want to pause and do the same thing, or I suggest maybe doing the back of your test review. Okay. But I'm going to just kind of do just a blanket kind of cheat sheet right here of everything functions. All right. So I'm going to kind of start where we started on the first day of functions. And we're going to first just talk about the very basics. We're going to look to determine if anything's a function, right? We look at a set of x's and y's, whether it's a table, a graph, we always have those plain old x and y's. And we very simply are looking to see if it's a function or not a function, right? And we learned that to determine that, we would have to determine if every x has its own y. Okay, and so remember, this is recorded me, so I'm going to move kind of fast, but you pause and write as needed. So we determined from this, okay, well, it's a function, and y'all have been great about, covering up the y's because we don't really need to look at it. Then we're going to look at to see if every x is different, and then we can call it a function. If it's not a function, we don't deal with it again, because you've learned at this point that if it's not a function, that means if you graphed it, it would have a vertical line on it, that undefined slope line, and we can't have that at all. We've learned now in functions that we can have wavy lines, or we could have zigzag lines. It can be all of that and still be a function. It just wouldn't be linear function. And that's kind of where we went the next day with functions. So we determined if it's not a function, we're not dealing with it anymore. And if it is a function, well, that can break into two things. It can be a linear function. And a linear function has a constant rate, a slope, and it makes a straight line. So this is what we've learned to be like slope, right? It'd be that beautiful straight line that you could graph. You could look at the equation and clearly see it'd be a straight line. Or it could still be a function where every x has its own y, but it would not make a straight line. It would be nonlinear. Okay, and we took a couple of notes of those before. And if you're in my class, we took a couple of notes. This is kind of a cheat sheet for everyone. If you want to draw these pictures, I'm giving you big hints here. A good way to remember this is these curved lines. If they're pointing up or down, like you've seen before, okay, they're going to pass that vertical line test. Even though it doesn't look at it, and even though it's going to look like it's going to get really close, it's going to pass the vertical line test, meaning it's never going to have this. It's never going to be two lines right on top of each other, just like this one would clearly pass. 2 points are never going to be right on top of each other, making a vertical line. However, if those curved lines face left or right, see how these are facing up and down? If they face left or right, meaning like this or like this, okay? These, if you try to do the vertical line test, are going to immediately fail. This right here has two x's that have the same or have different outputs. This is an x that has an output here and an output here. So this is not just a nonlinear function. These two that are facing left and right, these are not functions at all. They would kind of fall in this category here. So if they are facing left and right, whether it's a curved line or anything like that, and we can see, well, wait a minute, this x, whatever these coordinates would be, have different y's, they're not a function at all. If it's up and down, even though it doesn't look like it, this line will still go on kind of diagonal for a long time, all right? So remember, full picture here, we're determining if things are a function, if every x has its own y, if it's a function or not a function. If it's not a function, that's because it has a line that goes straight up and down, or you found that it has an ordered pair that has an input that repeats like this. The input of 2 has repeating outputs, okay, therefore it's not a function, right? If it is a function, we then went into linear or nonlinear. And specifically with linear, I know a lot of students, Ms. Burett and mine alike, have asked me questions about linear function tables. Okay, so I'm going to actually work one out like this on your test review right now. So if you need to write any of this, now's a good time to pause. I'm going to switch to your test review, and we're going to practice doing the linear, nonlinear from a table. So we are on this, and I'm going to start with doing number one because these are two great examples of this. Okay, so if we're determining linear or nonlinear, that's kind of because we already determined it's a table. It's a function already. And I can check that by covering the y and clearly seeing in table one right here, all those x's are different. So I know it's a function at all. Now I'm focusing on the part on, does it make a straight line? Is it linear or nonlinear? So what I'm going to do is my change in y divided by the change in x's. Okay, and I talked about this a little bit in my last video where in 7th grade we could do y divided by x because everything started at the origin. But in 8th grade that is not true. We have to account for things starting at a y-intercept of 5 or 10 or whatever it may be. So what we're going to do is basically find a pattern to make up for that. So we're finding the difference here from the change in y. So we're basically doing 11 minus 8, which is 3. And then 5 minus 4, which is 1. So this change in y is 3, and this change in x is 1. So the change in y over the change in x. And if I continue this pattern, all the order pairs, and I get 3 over 1 or an equivalent value of 3 over 1, then it's going to be a linear function, and it would make a straight line. So if I get 6 over 2, that's okay, because that's a value of 3 over 1. And we could keep going. But if I get anything else that's not a value of 3 over 1 or 3, well, then I'd have to determine this. It's still a function because every x is different, but it would be non-linear. So let's keep going and say 14 to 11 is 3. 6 to 5 is 1. So again, so far so good. We have 3 over 1. 17 to 14 is 3. And 7 to 6 is 1. So still so far so good. Last one is 21 to 17 is 20, 19, 20, 19, 18, 17. So if we have this right here, okay, now for the sake of math, I'm going to say they are going to try to trick you here and see, like, if you stopped after green and said, well, wait, this is clearly 3 over 1. I'm going to just do mental math like I was doing and call it a linear function. You might have gotten tripped up here, okay? But if we have 21 minus 17 and we have 4, right? That's a red flag there. We have to say, well, wait a minute. 4 over 1 is not the same value. So good thing we checked all of them because this would be really close to looking like a straight line, and then it would end up being just one little hair off. So we would have to call this one, because of this one thing that's one off, it's not linear the whole way. So this would be considered a non-linear function. It's not a function. It's still, every x has its own y. It just is not going to make a perfectly straight line anymore. It's going to curve a little bit or kind of shift a little bit when it comes to graph this one. Okay? I'd like you to take a second and pause and go try this one right here, okay? And tell me if it's linear or nonlinear while this is fresh in your head, okay? All right, if you paused and tried it, obviously you'll be able to check the key at the end, but I'm gonna go and do 2 more in here. I'm gonna jump to number 6, okay? We're gonna look at graphs real quick. So determining linear or nonlinear right here, we are doing what I talked about at the beginning, is vertical line test. So here, these are tricky because it's going to look like it's going straight up and down, but if you actually follow the line, it's going to kind of go out and diagonal a little bit. And remember what I said about it's only going to fail the vertical line test if it's facing left or right. If it's facing up and down like this one is, it's actually going to pass the vertical line test, even though it's like a squiggly line. Basically, it never goes perfectly up and down like this. Okay, so this is actually a function, still a function. It's just clearly not a straight line, so it's a nonlinear function. It passes what we talked about earlier as the vertical line test. There's no 2 points that are on top of each other there. Okay. This one to me is always the easiest one. This is the one that we want to see on tests because you did this for literally a month when we learned slope, right? This has a starting point. It is clearly a straight line. It clearly passes the vertical line test. So we can easily call this one a linear function, okay? And I actually think this one is super easy. It's way easier than trying to remember the whole left or right when not pass the test thing, because the whole point of the vertical line test, if I draw a line, is it going to intersect that line twice? And this one clearly does. So a circle is obviously going to have a point that is going to hit this x-axis more than once. So this is not a function at all. This does not pass the vertical line test. This passed the vertical line test. It just wasn't a straight line. This passed the vertical line test and made a straight line. This is not a function at all. This has an x that has 2 different y's. So it has an input that has more than one output. So this is not a function at all. Okay? Again, pause if you need to write all those notes. I'm going to do one more with you. So far I've done number 1 and number 6. I'm going to jump to this page right here. Okay? And so since I've done an example with a table and a graph, I'm going to do a couple of the number 9 with this equation, and then I'm going to let you solve the rest on your own. So equation rules were the easiest one because we basically only told you that the only thing you cannot have in a linear function is an exponent that touches a variable, because an exponent that touches a variable will curve the line. So we are going to look at this, and we definitely want one like this because number 1, you know how to graph this. There's no exponent that's touching this. So we're going to call this linear. Okay. This has an exponent, so we immediately know that this is not going to be what we're looking for. And I did explain and teach in class that it could not be touching a variable, but you understand that an exponent is applied to everything that's inside parentheses. So this would be eventually applied to this x. So this would be nonlinear. Right away, we see an exponent on a variable on this one, so nonlinear. This is something you could absolutely graph. This is a y-intercept and a slope that's perfectly easy to see. This is linear. This is not an exponent. This is an x that is just simply being divided by 2. So this is actually something you can graph. This is linear. And then again, I have an exponent that is on a variable. So this is nonlinear. Equations are the easiest ones. That's not really a lot of work. That is everything you need to know. And there's really only a couple of questions on your test tomorrow, I'll be honest with y'all. It's going to focus on the table and the graphs a lot. All right. Don't forget on these right here, just a quick reminder, I'm going to let you try these on your own, but remember domain and range, this is an X and Y. Okay. Domain and range are just another word for input and output. Okay. So remember, if you are determining if, and I made a note right here, if they're functions. Oops, sorry about that. So you need to determine if every input has one and only output. So right away, I'm catching a red flag right here because I'm seeing that this 2 has an output of 21 and an output of 25, and that can't happen. So we kind of already know the answer for this one, if it's a function or not. All right. So you will get to see a key at the end of all of this. I really hope that this test review helped any student, whether you are mine or Ms. Bluen's right now. If you have a question before tomorrow's test, please email me any questions. All right. Have a good day.